I didn't even start it. All right, number 2, 5 units. Well, you could just add or subtract 5 to your x, or add or subtract 5 to your y, right? So my points could be 7, -4, -3, -4. 2, 1, 2, -9.
Or any point less than 5 units.
Okay, or we can think 5 units can be formed by this right triangle, 3, 4, 5. That's one of your Pythagorean triples, right? So when y'all studied the Pythagorean theorem last year, did y'all talk about 3, 4, 5 right triangles? Yes. Okay, so if I moved 3 in one direction and 4 in the other, wouldn't that create a total distance of 5? So if I took the x and add or subtracted 3 and took the y and add or subtracted 4, that would give me 4 other points. And then I could just flip-flop them. So there were a lot of points we could have come up with for that. Yes, sir?
We can write our answer on the test, number 2.
You shouldn't. I just didn't write down every possibility.
But if we did, would you change it?
This
What,
is...
possibility, or what's he asking?
You would be more specific about it?
Yeah, go ahead and give me the exact point. I said them out loud, I just didn't write them down. Okay, this one. Remember, we thought of it as the vector. What vector gets us from 6, -2 to -4, 1? And so we're going to do a horizontal move of -10, a vertical move of 3. So we have a horizontal component and a vertical component. That gets us to the center. So to get to the other endpoint, we would do the same. So now we know that the other endpoint of that diameter would be -14, 4. Now this is kind of a cool problem because there's a lot of circle-related stuff that could be an extension of this. You could find the circumference now. Because you have the 2 endpoints, you can find the length of the diameter, distance formula. And then you could do pi times that distance. Or we could find the length of the radius and do 2 pi times that distance. We could find the area because we can find the distance between these 2 points, which is our radius, and square it. So there's a lot of extension we could do with number 3. You might see some of that on your homework. Okay? Any questions?
No.
All right. Let's take a look at the answers to last night's homework. Okay, I want to talk about number 6 and my take on number 6. Number 6 was a scaling triangle. And to draw an altitude inside the triangle would have been difficult. But does an altitude or a height of a triangle have to be inside the triangle? No. It just has to be perpendicular to one of the bases. So what I did was I thought about this base right here, this DE being extended, and then I just drew over this horizontal. Do you see how this would be a height perpendicular to that base? So the height does not have to be inside the triangle. So on this one, I drew in this height perpendicular to this base, but it's outside the triangle, and that's okay. It can be. It was the easiest one for me. It was the one I saw the clearest.
What is?
And then I didn't even have to use distance formula because I could just count. If it's horizontal or vertical, we can just count the units. All right.
Number
Yeah.
number one. for
Number one.
perimeter, I got 15 units.
Yeah, I got 4.
For which one? Number what? The perimeter or the area?
Perimeter. I got the area right.
You got 15.
Mm-hmm.
Okay, did you find that 2 of the sides were 5 and the other one was 2 roots of 5?
Oh, you know what?
I've got
Do they not all equal?
AB is 5, I got AC is 5,
Oh, I
and I
see
got
it now.
BC
Yeah.
is square root of 20, which is 2 roots of 5.
Yeah, I see it now.
Okay.
I thought it was equilateral.
For number 6, I got the area right, but I got 4 and 26, but I didn't get 5 root 2. I got root 34.
Okay, you should have gotten the square root of 5 squares plus 5 squares. 25 plus 25 is 50 for DF. Do you have your work separated to where you can see DF real clearly? Because 3 minus negative 2 is 5, and 3 minus negative 2 is 5.
I put 3 somewhere.
Okay, gotcha. All right, any other questions?
Wait.
Number 5.
For EF, I got square root of 26, and then what did you do? Like, 'cause how did you get it?
Well, you got to add them all up. The 4 plus the square root of 26 plus the 5 roots of 2. And you can't really combine them, so it takes all of it, just written with addition.
Wait. Did you just count DE?
Did I count DE?
That's
Yes, because if it's horizontal or vertical, I would not do the distance formula. I would just count units on your coordinate plane. Any other questions? Okay, today we're going to do our last topic.
I
Yes,
have a
ma'am.
question on number 5. I got for like the perimeter 60 and then like the radical of 5. I'm really confused how you got.
Okay, so I found the length of one of these sides. And I found it by doing up 2 over 4. So this distance is 2, this distance is 4. So I used the Pythagorean theorem, which yields the distance formula. So I get 4 plus 16, so it's square root of 20. Square root of 20 breaks down into 4 and 5. So each side of this rhombus is 2 roots of 5. Well, a rhombus has 4 sides. So 4 times 2 roots of 5 is 8 roots of 5.
So I did that like, I got like the 20 and then I multiplied by 4 and then I wrote it down and I was like,
Okay, when you multiplied square root of 20 times 4, the 4 can't go underneath. It has to stay outside. Okay?
thank you.
All right. So these are the formulas that were on that worksheet, but we also talked about trapezoid yesterday.
And then our actually is supposed to be like this. This is for soccer.
All right. So those are the ones we should know for the quiz. I mean the test. Triangle is half base times height. Rectangle or parallelogram is base times height. Rhombus is 1/2 the product of the diagonals. And that comes from the fact that it's divided into triangles. Trapezoid we haven't done one, but this is a formula you should be familiar with. Half the height times the sum of the bases. Now, last night, on my son's homework in 3rd grade, he had this picture of a bin. What goes in the overlap?
Similarities.
What specifically that we have studied goes in the overlap?
Parallel. Oh wait, are you saying for the one where they both meet in the middle? Or
What is both a rectangle
a square?
and a rhombus? A square.
That's great.
Okay? All right. Where would the parallelogram go?
Rectangle.
Rhombus.
No. Whole space.
Yeah. Whoa. Oh yeah, because they're all
Parallelogram. Because they're all parallelograms, right?
because they all have one set.
Okay. His question is, where does the trapezoid go?
And it's all
In the center.
In the corner.
Outside.
In the corner.
It doesn't really belong, does it?
I mean, it does have one side. Doesn't it?
Right, but is it a parallelogram?
Isosceles trapezoid.
They only have one pair, and a parallelogram has to have two. So if we were, it was very. I loved the problem. I thought, ooh, I'm going to ask my students today. But his problem didn't give him this big space. He just had the two circles, and it had a picture of a trapezoid, and it says, where does the trapezoid go? And so the trapezoid would have to go outside of the
Oh,
bend,
I see. I thought
because it is neither a rectangle nor a rhombus.
I see.
I liked it. For 8-year-old, good question, right? All right.
I didn't do that.
We can get
Y'all didn't do that in 3rd grade?
No.
Okay. I guess it's 8 and 9 year
We're
olds.
still counting pennies.
Still counting. They're not counting pennies. They're doing really cool Venn diagrams. All right. So today we're going to talk about partitioning a segment, and this is our last topic for this unit. Okay. First of all, we have to know what the word partitioning means to be able to partition anything. What does partition mean to you guys? Put it into parts. Yeah, that's exactly what it means. You're right. You nailed it. So we're going to break this up into parts. All right. So for our first problem, we are going to take this line segment AB, and we're going to find some point P along the way. Where is P along the way? Is it here? Is it here? Where is it? Where is this point P along the way that would divide this line? So this is what we're looking for. We're looking for old point P. Where do we put point P so that it is 1/3 the distance from A to B? So we have this line segment AB, and we want to go 1/3 of the way on this directed line segment. Now, what have we used before that gives us a directed path? The distance formula would tell us the distance, but what told us how to get from A to B?
Slope intercept.
The slope.
What slope?
I guess slope kind of does, but does slope tell us where to stop? No? What have we used that told us how to go
Midpoint,
from A to B?
Vector.
A vector. Okay? So, we know how to use a vector to describe this path, the horizontal move and the vertical move, the horizontal component and the vertical component. What vector would represent from A all the way to B?
5, 9.
Okay, good. 5, 9. Now, do we want to go all the way from A to B? No. We only want to go 1/3 of the way. So we don't want that whole vector. We want 1/3 of that vector. So we do 1/3 of that vector. And my horizontal gives me 5/3. And my vertical gives me 3. So from point A, we want to follow this vector. So now what do we do to find that point B? All we do is A plus that vector should give us that point P, shouldn't it?
Yeah.
So A was the point, -3, -6. The 1/3 AB is 5/3, 3.
What is that sign that you put above AB?
Oh, this kind of like half arrow.
Yeah.
Guess what that half arrow symbol means?
Vector.
Vector. Yeah, that half arrow symbol means vector. I don't think I talked about that the first time we did it. Thank you for asking. Okay, so that's all we have to do. So point P should be the point. -3 plus, isn't -3 the same as -9/3? So that would be -4/3, -3. So let's see. Let's see if I put this at -3. Here we go. -3. Whoa, no, not you. Undo. You. Oh. Okay, so, it's kind of looking close. There we go. Does that look like it's divided that? Is that 1/3 of that total distance? Yeah. It's 1/3 of the total distance. So, here's the steps. You find the vector. That should be an E.
Are we gonna get notes on this or do you want us to take
These are your notes.
them?
Find your fractional distance. Times the vector. And then in this case, we're going to add to the endpoint. The reason we added it just to A was this was directed. Did you see it said from A to B? So it told me where it wanted it. What if it had said from B to A?
It'd be reversed.
We would do reverse, but we would subtract it from B, wouldn't we? We would subtract that from B. Okay, questions about that? All right, you try. Find a point Q that is 2/5 the distance from A, which is, we're still going to let it be the point -3, -6, to B, which is the point 2, 3. And I'm going to leave the work up there for the last one so you can follow along.
Did you get 2 18
I get
I'm so with 12. Wait, there's 6 plus 2 bits.
And 2 fifths times 9 times 3. That's 8. So that's how far from point A. We don't want to go all the way. We just want to do this here.
TJ, are you trying to take AP stuff?
Tomorrow's the last day.
No, you can do it today after school. My mom called me.
You can either calculator or you can say,
I give him 1/6 as the final point.
6 bits.
I got.
Hey, where did you get? We can't see that, TJ.
Oh, negative 6. Yeah. Well, no. Well, no.
I just saw it happen.
18 fifths would cancel out negative.
Where did you get all of that?
Taking a picture of my page.
Okay. So, what we're going to do is we're going to represent this distance from A to B with a vector. Well, I gave you the same A and the B, so we better have the same vector, right? So this is 5, 9. Now, this problem doesn't want us to go all the way from A to B. We're only going 2/5 of the way. So we have to take that vector and multiply it by 2/5. So we do 2/5 of the way. Well, when you multiply this 2/5, 2/5 times 5 is 2. And 2/5 times 9 is 18/5. So we're not going all the way. We're only going 2 right and up 18/5. From where? Where are we going from? We are going from A. Says from A. So we take A, which is -3, and we add the 2 to that. And -6, and we add the 18/5 to that. And that gives us -1, ruh-roh. Okay, -6. If I need a denominator of 5, don't I just multiply it by 5? So that's -30/5. So that gives me -12/5.
Oh, yeah, that's right.
Oh, I'm also.
Which
Oh,
you
wait,
could have written as
I got that right.
-2.5. I mean 2.4. Excuse me.
I got that right.
Awesome.
But I didn't do the. I didn't do
I
5.
I didn't get the negative.
I just added -6 to 18.
Because
Yeah, that's what I
it's the same thing I did with the 9 when you multiplied it by the 2/5. I didn't multiply it by 5. I multiplied it by 2. I multiplied it by the numerator. And I got the right answer both times.
Well, 2 times 9 is 18. That's what I did too.
Yeah, and then but instead of multiplying the 6 by 5, I multiplied the 6 by 2, and I still got -12/5.
We multiplied 6 by 2.
Yeah,
Well, 6 times 2 is -12.
-12/5. I put a 5 under it and multiplied it by 2.
What'd you do with the 18 then?
I added it and I got 1/6/5 as the final 4 then.
-12/5 is the final quadrant. This is the answer. Either form, they're the same thing.
I missed stuff then.
Yeah.
So I
You turn this. They have to have the same to add and subtract fractions.
Yeah,
they have to
that's
have the
what I
same
did.
denominator.
I put it in the same.
So this would have to have a 5.
I did that.
So
Yeah.
you had to multiply by 5 over 5 right here. That's all. Okay. Now, this one's a little different. Same idea, but a little different. This says find a point P that partitions a segment CD into a 1:3 ratio.
1/3.
Did it tell me from C to D? No. So there could be how many answers?
4.
2 of them. 2 of them. I could have a point here and a point there. It didn't say how to do it. So when it's not directed, when it doesn't say from something to something else, you actually have more than one possibility. Now the other thing, does this say a 1/3 distance?
No.
No, it says a 1 to 3 ratio. So we have to think back to what we know about ratios. Now, do you remember, because my son had one of these on his homework last night too. This is one box to 2 boxes. A 1 to 3 ratio gives us what kind of fraction? 1/4. Does everybody see that? To break it into a 1 to 3 ratio, we need 1/4 of the distance. Okay? So what you end up doing is you end up putting this number in the numerator and the sum of the 2 in the denominator. Okay, first I have to make sure everybody understands that. Okay, cool. And then you do it the same way. Then we're going to find the vector CD. What is it?
2.
4, 2. And then we're going to do 1/4 that vector. Just leave that door open. I've left it open every time, but somebody shuts it every time. So we're going to do 1/4 of that, which is what?
1/2.
1/2.
Can you
Now.
repeat that last part? You said what in the numerator, what in the denominator?
I put the first number in the numerator and the sum of the 2 in the denominator is what it ends up being. Alright, so this is, this is a vector, and I'm putting it in parentheses like it's a point. Shame on me, shame on me. These should be the pointy ones. Pointy one. There we go. Yes, ma'am.
Is 4/2 just the slope? Because I'm really bored to get
Remember when we did vectors?
Oh.
And we talked about what vector would take us from this pre-image point to the image point? And so, okay. Okay, now I've got all those. Please write them as vectors when they're vectors. Oopsies on me. Okay, so that tells us how far to get. Well, we can go that distance from here or that distance back from there, couldn't we? So we can say C plus 1/4 that vector, or D, if we want to go backwards, it's minus 1/4 that vector. Do you get that? So C is the point -1, 3. And so we'd be adding 1, adding 1/2. So that would give me the point 0, 3.5. D is the point 3, 5, but we'd be subtracting. So that would give me the point 2, 4.5.
Would you ask us for like one of them or both?
So we have 2 points. We have one at 0, 3.5. Does that look like it's a 1 to 3? And then we have another one at 2, 4.5.
Yes.
Yeah. So do you see how both of those points partition that segment? Now, if it had said from C to D, then we're only doing this one. This one isn't part of the scenario. Okay?
From point C, if it just says point C to D, that's just distance, right? Distance formula? Because it's one, not just the distance.
If it just wants a distance, it's distance formula. But if it wants you to give a ratio. All right, you try this one.
First one would have been number 2.
Oh, yeah.
Would it be 3 fifths?
It would be. Very good.
Blue, once you simplify, do you multiply or?
Add it to D, then you subtract it. So
Once you simplify your fraction,
you add a
you
negative.
add a multiply.
Yeah. Okay, when you're done, you can look up my solution will be there. I'm about to get rid of my box here.
Let's go.
Okay? So when you're ready, look up. All the work is up there. I am about to pass back the graded learning task you guys did the other day. Now, some of you did not show me work, and I couldn't give you the credit for the work. So, some of you have like an 11 out of 20 right now. I want you to redo it and turn it back in. If it says need work or work missing, you give me work. I gotta get this passed out. I Y'all are fine. Y'all need work. Yes, both of you get the same grade. Show your partner. Y'all are missing work on that one. But somebody can show me this side. I did the work.
It looks like everyone got.
We did it over here.
Okay, I tried looking at both sheets of paper. If I have missed something, just like circle it or star it or make it obnoxious.
It looks like everyone got 3C wrong.
I got 3C.
Some people left a decimal under the radical,
But you can't have it.
and you can't have a decimal under the radical.
What would you do?
Some people wrote it as a square root of 5/4, which is perfect. Because $1.25 is 5 quarters, right? So that's 5/4. But you can't leave the 4. You can't have a fraction. So it should have been the square root of 5 over 2.
It's
If we fix it.
Now David's not going to fix that one.
You just told us to, so it doesn't matter.
Yeah, you can't fix that one. The ones that say need work or work missing, you can fix those.
Can we fix that one in different colored pen? Just
Sure,
for us?
just for you, yes.
When I was doing the worksheet, like this, I
Oh,
was looking at this, and I was kind of working on numbers.
yeah, that's because you hadn't done all that.
Oh, it's minus
You hadn't done that. Okay. Okay. You had one problem left on the review sheet from the other day that you didn't know how to do. So finish up that one problem for homework, and then this is the rest of it. Yes. If you want me to regrade a question, turn it back in.
We keep going together.
If you have a chance to earn back. I did. Yeah. Did you? Or not?
I just have like this 5/4 wrong.
Oh, okay, never mind. You're done. You got 5 minutes. It shouldn't take 5 minutes.
Miss Willoughby, can you go over really quick how
Pull a
to,
chair back there and help Aaron. I mean, help.
So are we doing the front and the back?
Yep.
can you go over really quick TJ how to do something that like find the slope that contains all this?
They're from like old.
Problem right here where it says
That's pretty old.
parallel to this.
Harrison parallels have the same slope. So you find the slope of this line. Same slope. And that's rising.
How do you use
Oh, wait.
What you're going to do is parallel we're just going to go to the slope. Whatever slope you want. Right? Yeah, on that equation. And so that's what it's all about. That's all it is. That's fine because they're parallel. I didn't get them more. Oh. Okay, are they not coming back?
No, they're not. Well, I know Colin's not coming back.
Colin's not coming back because they have soft
Yeah, he
pictures
is.
right now.
We'll probably look on.
So that's what task he showed you.
Good afternoon, Sarasville. I have just an important announcement for our soccer players. Your pictures today will be in the stadium, not the auditorium, in the stadium. So please immediately after school, head down to the stadium. Thank you guys so much, and everyone have a great afternoon.
Miss Willoughby, did we turn it in here? Or just give it to you?